Can you see the question, the image on the board?
Yeah.
Okay, it simply says to graph this line. It asks you to graph this line on the graph sheet. So though it's already has been solved and there are different steps written over here, but I feel like if we do it manually, step by step, it would be better. So let us then copy the equation here. The equation is y equals negative 2/3. One thing, it's negative fraction. What does it mean? Let me just tell you. Suppose I have a fraction x over y. So either the negative sign is here, or we can just localize that sign to the numerator. We can go bring the sign negative sign towards the numerator, or even it can be written towards with the like together with this denominator. Both the three notations are similar. There is no difference in them, right?
Yeah.
Okay, so that's what we are given here. Let's say it's negative 2/3. So all right, I'll just copy it right here. It's negative 2 over 3 x. This is negative 1 given. Okay, so let us write down negative 1. Isn't it the simple that form only that we discussed? Y equals mx plus b?
Yep.
Yeah, so we can directly write down, we can compare it with that form. Y equals mx plus b. So
B.
yeah, what can you just tell me what's the value of m now?
Negative 2/3.
Negative 2/3. That's the gradient, right? And what about the
Yeah.
y-intercept?
Negative 1.
Negative 1, that's right. So that's how the two informations are given. So the very first thing we plot on the graph sheet is this negative 1. Right? Okay, in Australian curriculum, I used to teach one of my students from Sydney. So even there are two methods of doing the similar question. I'll tell you both the methods, whichever you prefer, you can just use that. Okay, so right now, okay, this is my y-intercept. Let's have this graph sheet. 1 second. Suppose this is my x-axis, and then this is the y-axis. Okay.
Yeah.
Now what to do, this is suppose, okay, this is y, this is x. What's the value of y-intercept? Negative.
Negative 1.
So the one way is, you can simply do, okay, we can also calibrate. It's not necessary that every time you use one here, two here like this. No, it depends upon you in which way you are comfortable. You could have, if suppose you have got a lot, like bigger numbers, then you would have assumed 10, 20, 30 like that. Or even you can have
Yeah.
dissimilar, like here you could have used 10, 20, 30, here you could have used 1, 2, 3, or even 5, 10, 15 as per your convenience with your common sense, right? But right now we feel like the values are pretty small, 1, 2, 3, right? So it's better to just keep 1 here, then 2, and so on, like this. You know that this is the origin, O, and
Yeah.
towards the left we have negative values, negative 1, negative 2, and so on. Similarly, in the upward direction, we have positive values on the y-axis, and as we move towards the downward direction, we have negative values like this. So we have to first of all focus on that term, that is y-intercept. We can easily plot negative 1, okay? So negative 1 is kept somewhere here. That's where the line will intersect the y-axis, right? But now the problem is where to fix the line. The line can be like this, or it could have been in this way, like from the same point we can have even infinite number of lines. So we don't really know where to fix the line. We don't really know where to fix the line. So what to do to just fix the line? Any idea?
Um, the gradient of the line.
Exactly. The gradient we have to consider this time. Gradient is something where we have to what to do. Like gradient is nothing but the rise over run. You already know that. Okay, I can just write the value of the gradient. The value for the gradient has been given to you as negative 2/3. So negative 2 we can assign to rise, and 3 can be considered as the corresponding run. So then what to do? From the blue point you see right now, we can assume that line 2 just go towards downward direction. Why? Just because right now we notice that it's negative. If it was a positive, then we would have gone up in the upward direction.
Yeah.
Just because it's negative right now, we can assume that to go in the downward direction. So the rise, basically, its rise is nothing but the kind of, you have to fall. So the point will fall towards the downward direction by 2 units right from the point where we are starting. So right from the blue point, we are just moving downwards by 2 units. However, the denominator is still positive, right? So we
Yeah.
move towards the right direction again here in order to get the another point. So once we have risen means we've fallen by 2 units in the downward direction, and we run in the horizontal direction towards right, we get an additional point. That's where we should stop now. So this is the what? This is the rise kind of, and this is the
Yeah.
run.
That's
2 units
right.
and 3 units. And once you got these 2 points, that's where we can fix the line. We can easily fix the line because it's, if you have 2 points, there is only one and only one, like one on, just one line passes through, a unique line passes through 2 given points. So that's the exact line that we had to consider. The only thing you have to remember that this should be arrows at both the ends. The line never stops, it keeps going on in both the direction. So we draw the arrowheads like that. And that's the graph for the given equation. Okay, any doubt in this?
Not really.
All right.